All right, and we're back with another video in our exploration of equations. This one is multi-step equations with me, Mr. HÖEHN. So our central question for this video is, how does what I know about solving one-step equations and two steps help me solve equations with variables on both sides? Let's dive right in. So first, let's complete this chart. It's example A. A wireless company offers two cell phone plans. Plan A charges $24.95 per month plus 10 cents per minute for calls. So $24.95 per month plus 10 cents per minute. Plan B charges $19.95 per month plus 20 cents per minute. So $19.95 per month plus 20 cents per minute. So we're going to use the questions to find when the two plans cost the same. All right, so what I'm going to do is I'm actually going to solve each of these given this chart. So I'm going to start by plugging in 10 minutes for plan A and multiplying 24.95 equals 0.1 times 10 equals $25.95. Do the same thing, but I'm going to increase the minutes in the second line of the chart to 20 because each of the minute totals increase by 10. So 10 minutes, 20 minutes, 30 minutes, 40 minutes, so on in the chart all the way down to 70 minutes. So when I plug in 20 minutes, of course, I get $26.95, and I notice that this is just increasing by $1 each time. So that lets me complete the rest of my chart. So for 30 minutes is $27.95, 40 minutes is $28.95, 50 minutes is $29.95, 60 minutes is $30.95, and 70 is $31.95. So I can do the same thing for plan B. So $19.95 plus 2/10 times the number of minutes. So of course the first line of my chart is multiplying times 10 minutes. So 19.95 plus 2/10 times 10 is 21.95. Cool. Using the 20 minutes, or judging for 20 minutes, it turns into 19.95 plus 2/10 times 20, which is 23.95. Now I notice that these are just increasing by $2 every 10 minutes. So that lets me fill in the rest of my chart, and I've got $23.95 for 30 minutes, $27.95 for 40 minutes, and $29.95 for 50 minutes. And that should sound familiar. Because see, at 50 minutes, they cost the same. And that's what that question is asking me. So I'm not going to fill in the rest of the chart. So I'm done. But there is another way to solve this problem. I could actually just make this two equations and make them equal to each other, because that's what the question is asking. So let's take a look, and this video explores what to do when we solve those problems with variables on both sides. So let's solve it in a different way with example B. So my equation is 7x plus 4 equals 9x. So I'm going to solve that equation. 7x plus 4 equals 9x. So what I like to do when I'm solving is I like to move the smaller x. Now, smaller on the number line. So -1 is definitely smaller than +1. -10 is definitely smaller than 5, even though the absolute value of -10 is bigger than 5. Some teachers say always move it to the left. Other teachers say move it wherever it's convenient for you. Others tell you it doesn't matter. In fact, all three of these teachers, including me, are all correct. It doesn't matter as long as you do it. Pay attention to detail and make sure that you are solving your equation correctly. All right, but let's dive back in. What we've got here is moving the smaller x. That smaller x is 7x. So that leaves me, and the inverse of a positive is a -7x, so that gives me 4 equals 2x. The inverse of multiplication is division. Divide each side by 2, and 2 is equal to x. So I'm going to read example C and D. Go ahead and pause the video after I'm done reading them and solve them on your own. No, there's no answers in the video, but you can solve them the same way I did example B. So example C is 8a equals 5a plus 21. 8a equals 5a plus 21. Example D is 3x minus 7 equals 8x plus 23. One more time, it's 3x minus 7 equals 8x plus 23. Go ahead and pause the video and work those questions out. I'll be here when you get back. So I love playing this game in my class. For example, it's where did HÖEHN make a mistake? So my equation is 3x minus 2 equals 8x plus 13. Now, I'm going to read my steps on this equation as if I did them all correct, even though we know HÖEHN made a mistake. A dum-dum-dum. So the original equation is 3x minus 2 equals 8x plus 13. That's 3x minus 2 equals 8x plus 13. So my first step in my work is not to move the x, which is fine. I moved the positive 13. So the opposite of positive is negative. So I subtracted 13 from each side. So the 3x comes down and I have negative 2 minus 13. Well, 2 less than 13 is 11. So I have 3x minus 11 equals 8x. Sweet. So now I'm going to move the smaller x, which is the 3x. So I subtract it from each side. Because this is a positive, I make it a negative. The positive 3x becomes negative 3x from each side. That leaves me with negative 11 equals 5x. And this is simple. Inverse of multiplication is division, so divide each side by 5. And of course, negative 11 rather, divided by 5 is negative 2.2 equals x. And that's wrong. So the real challenge here is to discuss with your neighbor, partner, dog, fish, cat, and or person in your classroom where I made that mistake. Go ahead and pause the video and I'll talk about it when you are done figuring out where I made that mistake. And we're back. Yes, negative 2 minus 13 is not negative 11. In fact, negative 2 minus 13 should be negative 15. So in my last step of work, I should have 5x divided by 5 equals negative 15 divided by 5. Negative 15 divided by 5 is negative 3. I was wrong. But that's the game. Where did HÖEHN make a mistake? So let's keep on going. We're going to write and solve an application problem. Now, fair warning, people, this one's going to be long. I like to talk fast, but that's why there's a rewind on the video. Let's read. Example F. The length of a flag is 0.3 foot less than twice its width. Okay, so I know its width is x. I don't know that. But I know that the length of it is 2 times the width, or 2x, minus 3/10. Okay, cool. So I've got these pieces of information to go along with my first sentence. If the perimeter of a rectangle is twice the length plus twice the width. Okay, so 2L plus 2x, okay, equals my perimeter. Okay. If the perimeter is 14.4 feet longer than the width. Okay, all right, so the perimeter is 14.4 feet longer than the width, so 14.4 plus x. Okay. So I got a lot of stuff. I know that the perimeter 2L plus 2x equals 14.4 plus x. Sweet. I finally have a two-step equation, and I know what length is. Length was one of the first things they gave us. It's 2x minus 3/10. So I'm going to substitute in the 2x minus 3/10 for my L in my pink equation here at the bottom. So now the equation that I'm solving is 2 times the quantity 2x minus 3/10, closed quantity, plus 2x equals 14.4 plus x. So step by step, don't get overwhelmed. I'm going to do one thing at a time. The first thing I'm going to do is I'm going to distribute, because I see I have 2 outside of parentheses, so I'm going to multiply this 2 times each term inside the parentheses. So 2 times 2x is 4x, 2 times 3/10 is 6/10. So now my equation is 4x minus 6/10 plus 2x equals 14 and 4/10 plus x. Okay. I see 2 terms, the 4x plus 2x. I can combine those terms. 4x's plus 2x's is 6x's. So after combining terms on my left-hand side, I have 6x minus 6/10 equals 14 and 4/10 plus x. All right. So now this is getting a little bit better, because I can move the smaller x, which is x. So I'm going to subtract x from each side. And that leaves me with 5x minus 0.6 equals 14.4. Two-step equation. Add the 6/10 to each side. The inverse of subtraction is addition. That leaves me with 5x equals 15. And the inverse of multiplication is division. So I know that 5x divided by 5 equals 15 divided by 5. And if you are shouting at your computer screen that x is equal to 3, that's because you're right. But you're not done. Big problem. So now I know that the width is equal to 3. So in the last part of my problem to solve this, I can substitute in x, or the width, to my length equation. So 2 times my length, which is 3, minus 3/10. So 2 times 3 is 6. 6 minus 3/10 is 5.7. And now I know the length is 5.7 feet and the width is 3 feet. And that is the dimensions of my flag. Boom. So deep breath and rewind that video because F is long. And you can definitely watch me solve example F or listen to me solve example F every single time until you get it. And I suggest that you do that now. But when you're ready to move on, I'm going to read example G and H twice and go ahead and pause the video and solve them. No, there's no answers, but it is a check on your understanding for multi-step equations. So example G, 8x minus 2 equals negative 9 plus 7x. That's 8x minus 2 equals negative 9 plus 7x. Example H is 5p minus 14 equals 8p plus 4. 5p minus 14 equals 8p plus 4. Go ahead and pause the video. I'll be here when you get back. All right, the last two problems. So we're going to GCM'ing the denominators. Okay, these are crazy problems. They look weird, INJ. They've got fractions everywhere. People are freaking out. Fractions called me, you guys. They like you. They love students in 8th grade or any grade level watching this. So how am I going to tackle this problem? So the key is, all right, my problem. Let's go back. My problem I is negative 10 thirds times A plus 5 thirds times A equals 35 sixths. Or, said a different way, negative 10 over 3 times A plus 5 over 3 times A equals 35 over 6. 3's and 6's at the bottom don't like. So the key is that 6 is a multiple of 3. And I can multiply each side times 6. And when I do that on the left-hand side, I see that the 3 cancels with the 6, and I know that 6 divided by 3 is 2. So when I do that, on the left-hand side, I get negative 10 times 2 times A plus 5 times 2 times A equals just plain old 35, because the 6 and the that you're multiplying cancels with the 6 that you're dividing the 35 with. So now this is a multiplication problem. Negative 10 times 2 is negative 20. 5 times 2 is 10. So I have negative 20A plus 10A equals 35. I can combine the terms. So negative 20A's plus 10A's is negative 10A. That equals 35. So negative 10A equals 35. And the inverse of multiplication, say it with me, is division. Divide each side by negative 10. A equals negative 3.5. I'm not doing J, people. That's your work. So I'm going to suggest that you rewatch I and see what I did in each step. And the key was seeing that the multiple of 6 is a multiple of 3. So going back to example J is 3/4 x plus 3/2 x equals 9/4. Or said a different way, 3 over 4 times x plus 3 over 2 times x equals 9 over 4. So go ahead and pause the video, solve J the way I did I. I'll be here when you get back. And ladies and gentlemen, if you're in my class, write your summary and update your table of contents. But if you're not, and you're watching at home or you're watching through the interwebs, keep doing the math.